Hey guys, it's Monster Cameron here, and welcome to episode, was it 6 of Cup of Java. So we just did our very first game actually, with if statements and random numbers. Very simple game. It's just rolling the die. I don't really want to. It shouldn't really be called a game, but it's the beginnings to games. And but whatever. So we did if statements. We did random numbers, and I even attempted to do it on my own first and see how the example was actually written, which I wasn't that far off actually. And I did learn a couple. I did learn a couple of things about how he did the example as well. So can't say that we're not learning. So let's jump straight into it. Man, yeah, I got a bug. But anyway, so right now we're doing. Let me see if we got it right. We're doing switching. Case switch. Alright, so Java, much like railroad tracks, incorporates switches to direct the path of execution. So from what I understand, a switch is that you have a variable, and it has multiple. It could have multiple values, and the switch basically execute the code that's aligned with the variable. So if the variable random int was, case 1, you do the code associated with case 1, or if it was case 2 or case 3, you do the code associated with that. So when would you use it? A case switch? Maybe when you have multiple objects that are similar. I don't know. Well, we'll see how far the example takes us. Okay, so we're actually just going to copy this and run it and analyze it a little bit. Okay, so let's do this here. So random rand is a random object called rand. New random. And the reason why it's throwing an error is because I haven't imported the random class. So if I do a Control-Shift-O, it will import it for me. And that's an error because of mistyping. Alright, so let's define random int as a integer. And now let's seed rand with the max value that we want. Oops, a little bit of freezing there. FFmpeg, Eclipse, all the stuff I have in the background, and Unity can take its toll. System. Why are we doing this? Alright, so we're gonna print the random value. Int, and this should be capitalized, capitulate, and that's alright. So now I want to switch parameter. I wonder what's the reason for the curly braces? Or the braces? Or are they brackets? Which one is which? I should really check that out. I've been asking that question for like 2 episodes. So, if case 1, print heads. If case 2 is 0, print tails. That's similar to what we're doing with the if statements, but it's with a lot less code in the way. And I don't know what would be the benefits of using a case instead of just using a bunch of if statements. Oh man, maybe we'll show that. Maybe we'll explain it in the example. Case 0. so head tails brick. Did I miss something? I gotta terminate that. Bam, bam. So will that run? Let's see. It should run, right? Okay, it did run. Okay. Oh crap, what am I doing? Shit. Alright, so the code does run. So let's... let me see what it says. Let's examine switch in detail. Inside the parentheses, you write the variable name that you are testing. If the variable is an integer, you write case 1, and so on. If it's a boolean, or you write case true, case false. If it's a string, you write case... damn, I'm blanking on the word. Quotes, or... quote... why am I blanking on the name of a... whatever. Tired. The purpose of the break is to separate the classes. The cases classes. If you forget to put the break, the code will not stop executing. Okay. Applying the example above, what if we're testing an integer called random int? If random int is 0, computer will output heads. If random int is 1, computer will output tails. What would be the practical application of this code? Let's say we have a game in which a player can select 3 main characters. Let's say Mario, Luigi, Yoshi, of course. We could create a string. Alright, we're back. So, where were we? Okay. We would then create a string variable that holds the value of the names, then use a switch to carry out the appropriate response. The following will only work in Java 1.7. If you have 1.6 or below, just look through it to see what it is doing. Okay, that's fairly simple stuff right there. But why would you... The use of the switch isn't what I'm wondering. Why would you use a switch instead of case? I mean, why would you use... fuck it. Why would you use switch instead of an if statement? It's tough to figure out. Alright. Looping, alright. And if you want to, you can go and follow there and donate. Alright, so I still don't get the purpose of using switch instead of like if statements. But I guess it's gonna be a scale thing. If you're doing multiple conditions on like a singular object, or multiple objects with similar parameters. I'm confused. Dazed and confused. Alright. But I do get the syntax, and I do understand how it works. So that's all that's needed. Okay. So this one's a little bit tired. So there we go. Oops. How did I get to the end of the page so quickly? Alright, so we're gonna do some looping. Alright. When is a loop useful? A simple scenario. If you wanted to output a specific line of text 100 times, one solution would be to copy and paste a system output print line statement 100 times. This is not very effective for for both the program and the computer. Instead, a proper solution would be to utilize a loop and to counter one or to execute. To counter or to execute one line. More practically, more practical and relevant. My God, I'm just failing on every level right now. We will have a hefty discussion about this crucial loop later. Okay. A while loop. I do get the syntax for the while loop. That's not a problem, really. All it does is it just executes the code. It just keeps executing the code. I'll be right back, guys. Alright, a little bit of distraction there. So here we go. So while loop, very simple to grasp. Very simple to grasp. It just keeps repeating until the condition is not true, right? Player is alive equals true. It will keep looping. But if it's false, it will close the loop or break the loop, and you can break it manually as well. Alright, so we got while loops. Now we're going to do analyzing looping class. In this last lesson, I created a class called looping as followed. Okay. Alright, so let's analyze it for myself. So the looping class, public looping class, we created the main method. Create three integer variables: initial value, final value, and counter. And then we created an if statement, and if the condition initial value is less than final value, it prints a bunch of stuff with the print line method, system out print line method, and it updates the counter. What does the counter do? And while initial value is less than final value, it updates initial value. So eventually initial value will be greater than final value, which will break the if condition. It will break also it will also break the while loop as well. If initial value is equal to final value, then it prints a bunch of stuff as well. Else, I don't know why I marked this out. Executed if initial value is less than final value, above is not true. Okay, I see what it says. This is like representative of what the else is. So the if would be true, the true path, and else would be the false path. Okay, that makes sense. System out print line final value is this initial value. Okay, so I understand what it's doing there. The for loop. This is what really confuses the hell out of me every time I look at it. Alright, I gotta really pay attention now. The while loop utilized a counter that we coded ourselves. Now we will implement the for loop, which comes with a built-in counter, so to speak. The form of a for loop is as follows. So for initialization, termination. So start value, end value, and how much to increment it by. Then code. is executed, right? When using this version of the statement, keep in mind that the initialization expression initializes the loop. It's executed once. Okay. When the termination expression evaluates the false, the loop terminates. The increment expression is invoked after each iteration of the loop. It is perfectly acceptable for this expression to increment or decrement a value. Confused? Just a little. Let's see how it works. Alright, so for loop class, public, you know, maybe I should do it. Just have like a feel for it, because it always slipped me by. Or slipped by me. Which one's better to say? God darn it. So, and then, oops. I still gotta find out what the static thing means. What was that? Oh man, it is just really not my day. Nope. For condition int variable assign 1 semicolon variable is less than 11. So termination. So start, termination, and then increment value, increment, decrement value. Variable is incremented, and code executed until variable is less than 11, or while variable is less than 11. I don't understand. Well, let's see what the code does, and let's see if I can follow that instead of just the syntax. So variable is a local variable. I'm just not in it today, am I? Terminate that tab. Let's run the code and see what happens. So basically you'll keep looping until variable is less than 11, or you will keep looping once variable is less than 11. Let's see what the example says and see the wording for it. The second part, variable less than 11, is the condition. Think of this as while variable is less than 11, everything inside the loop will run as long as the second part is satisfied. Okay, so it is while variable is less than 11. Okay, so I got that down now. And I guess variable plus plus could actually be any value, or could it be like just one? Would it keep adding one for every loop, or it could be two, and would it keep adding two every loop? Now I'm a little bit confused. Let me see the results that I had. Because what I was thinking is that if it's like variable plus plus, I mean, for example, a variable would be equal to 1, then variable plus plus would be 2, and it's, if it like, as it, does it modify variable itself, or does it add to variable for each loop? Or, and would I have to do my own, like, wow, I am confused. Alright, so initialization, termination, increment. So I would have to do the incrementing myself in that section. So it'd be like, if I wanted to increment by 5s, I'd have to do variable plus 5, and not necessarily just leave 5 there. Let's see what the example is saying. For loop. Alright, so here it is. I'm not really doing anything about. So it does seem like I have to do the incrementing on my own, and the for loop won't do it to the initialization by itself, initial value by itself. So this could be anything really, right? It doesn't necessarily have to be targeting initial value. Alright, let's move on. Inheritance interface. So, not much to do for the for loop. This would be a good example for now. Wow. Damn it. Alright, let's move on. Day 10. Today's penultimate, not a lot of time left. This lesson will be discussing inheritance and interfaces. Not in not in extensive detail, as they will come up frequently in the future units, and the easiest way to understand is when you play it them yourself. So interfaces. Alright. Class name implements interface name. So if you've ever seen highly functional Java code, you might notice something like this in the class declaration. This line of code creates a class name, and implements the interface name. What does that mean? Yeah, it's quite a mouthful, I agree. So you can think of it this way. Simplify for me, please. An interface is a collection of abstract, meaning that it's not really used, but it's just there as reference, methods and constants that define a group. Okay, sure. If a class implements this interface, then it will inherit all abstract methods and constants. For example, interface human, method eat, walk, pee. What does that mean? We can also have a class named king. King implements human. Is it just like a pointer, like a reference? So when class king implements human interface, the class is basically applying every abstract quality of the interface human onto itself. In other words, king is saying first and foremost he is human. When you implement an interface in a class, you must define everything you have defined in the interface. That means the king cannot remove p method from his class because he is, after all, only human. That doesn't make any sense to me, but we'll see where the example goes. This is a very similar topic to interfaces. The key difference is that inheritance deals with two classes, not a class and an interface. Another key difference is that inheritance uses keywords extends rather than implements. So how is extends different from implements? Recall that when you implement an interface, you must take all qualities of the interface. Okay, apply it to a class that it is implementing. That is implementing it. So when a class extends another class, we refer to it as a superclass, and extending class is called subclass. A class is a blueprint for objects, as I have repeated over and over. A superclass is a blueprint for other classes. Alright. A class phone. A couple of local these are class variables. Weight, number of processing cores, price. And then there's a method. Turned on equals not is a sign not turned on, or what is the above line of code toggles the value of a boolean. So false, true or false. Basically, is turned on is the opposite of what it used to be. Doesn't make any sense. Whatever. Using this superclass, we create a subclass which will add this, which will this key add on to methods described in the superclass. Okay. iPhone extends phone boolean has Apple logo true string color black adjust price if has upper price plus equals 450. That's a little bit of poking fun around, but I still don't understand. You gotta use it for real. I still don't understand what any of it means. Now this class iPhone will be able to use all methods and constants defined in the superclass phone. Is it like a group of methods? That's basically what a class is. I don't get it. Inheritance. What's it called? Inheritance interface. So I think we just did all the basics of Java, even though for for loops I'm still fuzzy on, and for inheritance and interface I just don't understand or see uses for it yet. But I guess we'll find out when it gets a little bit more complex. Alright. Alright, so if you want to, you can support these guys. You can get their Tumble Plus from the Play Store donation, or you can help grow their fan base on Facebook or linking to their blog, which I'm pretty much doing. Threads. So far in Java, we have followed a simple and general rule. When you press the run button, the program runs line by line from top to bottom. Okay. Excuse me. When you start game development, however, you may realize that you require simultaneous processes for your game to work. This is where a thread comes in handy. As the word thread may suggest, a thread is a single lightweight process that you have multiple threads. When you have multiple threads, these processes are carried out simultaneously. How do you create a thread? How do we create a thread? It's interesting. The method is similar to how we create a random object. To create a random object, type random, variable name, random. Oops. I think we're too invested in it to finish here. We're gonna see how long it takes us to get this one. How to create a thread? We do the following: thread, type thread. We're creating a thread object called thread, and we declare it new thread method. Man, I'm just not in it today, but I'm not gonna give up. This creates a new thread called thread. Okay. Unlike random objects, however, creating a thread creation of thread objects is a bit more of a lengthy process. Threads require a built-in run method, and we'll incorporate it directly into the statement above. Alright, so I'm gonna do a new class to mess with this. So class, we're gonna call this needle and thread. I'm bored. Oh, no white spaces. There we go. And we're gonna get the main method up and running. So public static void main string args. Still don't get that, but I'm gonna leave that. And this has to be capitalized. This is gonna be the end of me. Okay, let's create that new thread and give it some life. Thread method. Alright. Public void run method. That's inside of the thread. Strange. That's some weird syntax. Alright, so thread, we do curly braces. Come on, eh? And then we do public void. I know void means it doesn't return a value. Alright, let's read up a little bit. We begin like so, adding braces to the end of the statement. Now, these braces will contain the run method, which is again required for a thread. I know this is new for you guys, so just try to apply your knowledge of hierarchy in code when you examine the next part. Okay, so we have that copied, and we created a new thread. So basically, we're creating. Is this like making creating a method right here, or why is the syntax like this? I don't get it. Or is this the thread method? I don't get it. Well, we'll see what happens. When you want this thread to start, you would type a built-in Java function, meaning that it is already defined by the language when you use with a thread. Dot start. Okay, so this is actually just defining what's going to be inside the thread. But in order for you to start it, you're going to need to use thread name, thread object name dot start method. When the thread is started by dot start, it looks for the thread's run method and begins to run the lines of code there. At the moment, it is empty, so we will add a few lines of code. Alright, so let me just copy this. So for loop. So what does this say? I think I broke something already. Oh, we gotta terminate that. Oh, it's already closed. Why are these giving issues? Oh, we gotta do another one. So it's very nested. Oops, what am I doing? Okay, so for int I equals 0 and while I is less than 10, I plus equals to 2. Okay, so this is how you do it. So I'm a little bit less fuzzy on for loops. So you can adjust how much you want to increment it by. And it's per, you increment it a variable. So you don't necessarily increment the initialization variable. Okay, that's just gonna print hello 10 times. Okay. Or 5 times actually, because they're doing 2. Let's see if this runs. So we haven't had an issue. It won't run because we haven't called the thread start. So do we do thread start before or after? Well, let's continue on. Okay. So they're gonna be okay. So they're gonna be two threads. So I gotta copy paste, and let me get some commenting in here. Thread 1. Let's go to thread 1. It's not really helpful, is that? Thread 2. Now down here. Starts any. So it's thread 1 dot start. Man, I'm already doing multi-threading. But who's gonna get priority over the terminal? It's gonna be like inter-threaded. It's gonna be like the first results for the results for the first thread, then followed by the second. Right. Let's run it and see what happens. Hello to. Okay, it's just as I imagined. So it completes the first thread, then the second thread. That's very sequential, really, is it? Alright. Now let's discuss step by step what happens when you run this code. Of course, as with all Java programs, when this class is run, it will look for the main method. The main method contains 4 blocks of code. The first one creates a thread called thread and defines its run method. Okay, the second one creates a thread called thread2 and defines its run methods. The third one starts thread 1 and the fourth one starts thread 2. Hold on, I mentioned that a thread allows simultaneous processes. Why didn't it alternate between thread 1 and thread 2? That's what I was thinking at first. We'll discuss this in Unit 2. Stay tuned. Nobody likes programs run on a shell like DOS. People like GUIs. Oh yeah, graphical user interface. That they can interact with. Functionality is important, but interfaces are often more so. Now we begin our discussion of graphics. I'm just so out of it. Oh my god, it's right in front of me. There is so much talk about graphics. We will just adjust. Oh my god. Alright, just focus, man. So we'll just upon a few statements that allow us to display graphics. Note, when I use the word graphics, I'm referring to a digital image and not game graphics, so keep that in mind, of course. In this lesson, we're first going to create a window which can display images and then try to displaying some graphics on that. To start, create a class called Graphics Demo in Eclipse. That's doable. Class, this graphics demon. Alright, graphics demo. I don't know, should I just start the main method? Is Jframe part of standard library? Alright. Do I do this within? I'm assuming I do this inside the main class. Extends is inheritance. Right. Swing Jframe. I'm thinking it's not supposed to be there. Oh, I think it's supposed to be one line. Let's get rid of this. Okay. So, what's this swing thing about? One of the first things we talked about in Unit 1 for game development is that classes are blueprints for objects. We never really discussed how this works. In this lesson, we will use Graphics Demo class to create an object, much like we created a thread object above. So to do so, we add a constructor to our class. A constructor is basically a set of instructions for creating an object. Okay, so I'm just gonna copy paste most of the stuff or just type it in. The constructor follows. Okay, so I'm just gonna public graphics. Oops. Public graphics demo. All classes need a main method. Okay, so we do need to create a main method. Let's see. Well, I guess that's a given in any situation, or I don't know. We'll figure this out eventually. Oops. Why is Args here? I've been doing... Don't tell me I've been messing up for forever. Oh my god. I've been messing up forever. No one's stopped me. Args. So why didn't it throw errors? Or is it really inconsequential? Okay, so now we're doing constructors. Graphics demo equals graphics. Alright, this will create a graphics demo object in the main method like so. This should be familiar as we used to create this to create random objects and thread objects. Okay, so that's a constructor. Okay, the statement above, oh my god, the code above, really? The above code, when executed, will look for the main method. This main method contains one statement: graphics demo, new graphics demo method. When this statement executes, you will be creating a graphics demo object using the constructor, so named because it's used for construction of objects. Okay. Of the graphics demo class, and the name of the object will be demo. So at the moment the constructor is empty. So when graphics demos object is called, so when the graphics demo object called demo is created, it will have no function. So we proceed by adding a few built-in statements that belong to the Jframe superclass. So we can utilize these because we imported Jframe in the first line of code. Alright, so let me copy that. So these are functions or methods of Jframe. The first four statements within the constructor are self-explanatory. Set title, set size, set visibility. The final statement just allows the windows to close properly and terminate the program. Exit on close. We now add constructor back into place. Alright, let's run it. There we are. We have a blank window. And it's got GDK ish. You know what, guys? I think that's gonna be it for today. I'm bordering on fatigue, and I'm getting a little confused if we keep doing this. So we'll continue tomorrow, and this has been an extra long episode. So I think that's gonna be it.